All right, today we're going to pull back the curtain on one of the most powerful skills you can learn in the 21st century, programming. We're going to completely demystify what code really is, and I'll show you how you can start speaking the language of computers yourself using one of the friendliest languages out there, Python. But seriously, have you ever really stopped to think about that? We type on our keyboards, we click a mouse, and it's like magic happens on the screen. But what is actually going on under the hood? How does this machine, this thing made of silicon and metal, actually understand what we want it to do? That's the big question we're going to unpack. So, to get our heads around how a computer thinks, it's actually super helpful to start with the original computer, the human brain. We're going to look at the fundamental little switch that powers our own thoughts, and then see how engineers created an electronic version that works on a completely different level. And this is where it gets absolutely mind-boggling. See, our brain's building block, the neuron, is a biological switch. It's amazing, but it's kind of slow. It takes about a millisecond to fire. Now, compare that to the computer's version, the transistor. It's just a simple on-off switch, but it can fire 8 billion times a second. So while our brains are all about complex connections, computers get their power from just raw, blistering speed. And believe it or not, this is where it all started. This thing right here. It's not some sleek microscopic chip. It's this clunky, hand-put-together contraption from way back in 1947. But this first transistor, this was the seed. It proved the whole idea of an electronic switch could work, and it kicked off the entire digital revolution. And that revolution took off at a pace that's hard to even wrap your head around. It's famously described by Moore's Law. Basically, one of Intel's founders, Gordon Moore, noticed that the number of transistors we could cram onto a chip was doubling about every 2 years. And boy, was he right. Just look at this graph. We go from a couple thousand in 71 to billions on a single chip just 40 years later. That explosive growth is exactly why the phone in your pocket today is more powerful than all the computers that sent humans to the moon combined. So you've got billions of these lightning-fast switches. What does the computer actually do with them? Well, it follows this simple, relentless rhythm, like a heartbeat. Fetch, decode, execute, and store. It grabs an instruction, it figures out what that instruction means, it performs the action, and then it saves the result. That's it. That's all it does. Over and over again, billions of times every second. Every single complicated app or game you use boils down to this one fundamental 4-step dance. Okay, so the hardware is ready to go, it's incredibly fast, and it has a really simple process for following orders. So now comes our part of the equation. How do we give it the right orders? This is where we shift from the silicon to the art of instruction. And the key concept here is something called an algorithm. I know it sounds super technical, but it's an idea that's as old as humanity itself. Really, an algorithm is just a step-by-step recipe for solving a problem. If you have ever followed a recipe to bake a cake, guess what? You've executed an algorithm. It's that simple. And just to prove that algorithms aren't some new, scary computer thing, check this out. This is the Babylonian method for finding a square root, an algorithm from almost 4,000 years ago. It's just a clear, logical process for getting closer and closer to the right answer. No computer necessary. At its heart, programming is just the modern art of translating these kinds of logical recipes into a language a computer can understand. But there's a pretty big catch, and this quote just nails it. A computer is an incredibly obedient servant, but it has absolutely zero common sense. It will follow your recipe exactly as you write it, even if your instructions are totally wrong. You tell it to add salt instead of sugar, it will happily bake you a very salty cake. So being precise is everything. So what we need is a language that lets us write our recipes with total precision, but also in a way that's clear and easy for us humans to read and write. And that, my friends, brings us to Python. You can almost tell just by looking at the quirky style of this book cover that Python tries to be a bit more approachable. It was designed from the ground up to lower what's called the cognitive load, which is really just a fancy way of saying it tries to make it as easy as possible to get your ideas into working code without getting tangled up in a bunch of confusing rules. And that was the whole mission of its creator, Guido van Rossum. The point wasn't to make the most complicated or technically brilliant language. The goal was to build something that helped people solve problems and create things more efficiently. It was built for the programmer. This whole idea is captured perfectly in a set of guiding principles called the Zen of Python. And one of the core tenets is this: there should be one
and preferably only one, obvious way to do it. The language is literally built to guide you toward clear, simple solutions. It chooses simplicity over complexity every time, which you can imagine makes it a fantastic language for learning.
All right, let's open up the toolkit. Just like any language has its basics, nouns, verbs, punctuation, a programming language has its own fundamental building blocks. So let's look at the absolute essentials. First up, variables. This is probably one of the most important concepts in all of programming. A variable is just a name that you create to hold on to a piece of information. The best way to think about it is like a labeled box. You can put something inside the box, like say the number 10, and you can write a label on that box, like my_number. From that moment on, whenever you talk about my_number, the program knows you mean the number 10 that's stored inside. So what kind of stuff can we actually put in these boxes? Well, data comes in different types. For now, let's just focus on the three most common ones. You've got integers, which are just whole numbers. You've got floats, for any number with a decimal point. And you've got strings, which is just the programmer's word for any piece of text you put inside quotation marks. Okay, next up, we need a way to actually work with the data in our boxes. That's where operators come in. These are just symbols, many of which you totally already know from math class, right? Like the plus sign for adding or the asterisk for multiplying. They let us perform actions on our data. And here is where things get really cool, and you get your first big aha moment. The same operator can act totally differently depending on the type of data you give it. So if you use the plus sign with numbers, like 2 plus 3, it does exactly what you'd expect. Addition, you get 5. But if you use that same plus sign with strings of text, it just smushes them together. So 2 plus 3 becomes the text 23. This is a huge idea in programming. The type of your data really matters. Okay, you ready? Let's put this all together. We have variables to store stuff, we have data types to say what kind of stuff it is, and we have operators to do things with it. With just those three simple tools, we are ready to write our very first program. Look at this. It's just 3 simple lines, but we can see everything we just learned in action. First, we make a variable, a box, called name, and we put the text world inside it. Next, we make another variable called greeting, and we create its value by joining the text hello with whatever is inside our name box. And finally, we just tell the computer to print whatever is in the greeting variable, and boom, hello world. That's it. That's a complete working program. And from this tiny foundation, the possibilities just totally explode. You can take these basic building blocks and start making really fun, interactive things right away. You could build a Mad Libs game or a Pig Latin translator. You could start playing with real-world data, make cool charts, graphical animations. Really, the door is wide open to build whatever you can imagine. So at the end of the day, that's what programming is all about. It's about looking at a problem, coming up with a logical recipe, an algorithm to solve it, and then using the simple tools of a language like Python to bring that recipe to life. So the only question left is, what are you going to cook up?